All right, so what I just mentioned that today we are going to do more on data exploration. So this something we've started before, but it's good to refresh what we have done, especially now that you have covered the topic central measures of a central tendency. All right, so we open this data set by logging into our SPSS, and then we come to file where we open, then open data, then we go to where it is, and then we open it. So we have our data set intact. By the way, you also have a copy of this data sets. So it is okay if you are with your computer and then you have SPSS installed on it. As we progress in this class, you can also do the same on your own computer. All right. Otherwise, it's okay. You can follow. The video will be available maybe before this before Monday. You can get your recording. All right. So here we are. So for you to explore data sets, you come to this analyze, and then you come to descriptives. Remember, the whole course, the whole 801 is about descriptive statistics. So we will not do more on that until we get to 802, where we talk about inferential statistics. That is where some of these things that you see below will be useful. But for now, we are still operating on the second item, which is a descriptive statistics. So now, in this descriptive statistics, there are now some options for you. We have the frequencies, descriptives, explore, crosstab, ratio, PP plot, Kiki plot, and so on. This plot, they are there for you. All right. So, but what we concentrate on for now will be the first two or the first three. Why the fourth one, which is crosstab? That this is where you do your chi-square analysis. All right, where you use statistical tool to analyze frequencies. Okay, this will be a topic for another day when we treat chi-square in class. We then come back to this crosstab. It's very important analysis. All right, so we start with frequencies. And in our frequency, I just say, let us start with gender. What is that? Let's explore gender. Okay, by the way, exploration is the very vital thing that you must start with in data analysis. Whenever you come back from your field, either for pilot study or for your main study, and you put your data in Excel or you put your data in SPSS, the very first thing you should do is this: explore your data, view it before you start any inferential statistical analysis. This must be done. Otherwise, you can make serious mistakes that will affect your result. So whoever that is analyzing for you, if you are not analyzing by yourself, tell the person to start with exploration of the data. The test of normality, they look for outliers, they look for missiness, and this test should be reported and should be reported in your thesis. This will let your supervisors, will let your examiners, will let your reader know that you are actually know what you are doing. All right. So you push in your, I can remove it from here. You just click on it and then you click on this arrow. It will come to where you want it. I want to explore gender. Then I say, remember, gender is categorical. 1 or 0, 1 for male, 0 for female, or wherever, 0 for male, and then 1 for female, or 1 for male, 2 for female, as the case may be. So these statistics will not make sense. By the way, this quartile started, look at it here, quartiles. That's what the topic is started. And then percentile is also there. Okay, but for now, we leave this. We concentrate on the description of it, mean, median, and mode. All right. So there is nothing much on the statistics because it will not make any sense. Then we come to charts. Maybe we can get something here because we're talking about gender, male and female. So we can know the component bar chart or simple bar chart or even pie charts. Okay, anyone is looking for you. You can choose bar chart, you can choose pie chart. Histogram may not make more sense because this is categorical. All right. The histogram will still be same as your bar chart. So now we take our bar chart and then we want frequencies. You have options. If you like, you can take percentages. And if you like, you can take frequencies. Let's start with frequency. Perhaps we go back to percentages. All right. So you see why I said we should not record now. So they will disturb the video for others to watch. Okay, so we have our chart here, and then we have display frequency table, and then we click on OK. All right. So by the time you do that, you have this results. The very first thing you see here is about the number of participants that you have. So you can see valid cases, we have 131. The missing, there is only one missing. That means out of 132 respondents to this questionnaire, one person skipped the gender. One person did not declare whether he is a male or she is a female. All right? That is what this missing is telling you. And by the way, this missing, if it is much, it can affect your result. So there is another analysis for you to test whether your missing is what? Is much that can affect your result or not. All right? So, but for now, we keep that for later use. All right. The second table you see here is about the distribution of your participants. So you have the valid cases for male. There are 75 males and there are 56 females. The percentages are here and the total is 1 with one system missing. All right. Then what about the bar? You know, I requested for bar chart. Now, just give me the bar chart, right? You see the frequency. Remember, we have two options for bar chart. We can take the frequency or we can take the percentage. For now, we are taking the frequency. So the number of male, you see I up here, and the number of female follows because there are more males than females who responded to the questionnaire. All right, so we can go back there. Perhaps I also want to look at the percentages. Okay, so we come to our chart and then we choose percentage instead of a frequency and we click on continue. Okay, there we have it. So the only difference will be in this bar chart. Right, you can see now. So we have male up here around 56 or 57%, and then female is down here around 40 something or 44 or 45%. So, and then the table is already here for you. You can see 57% for male and then 42.7% for female. All these things, you can copy them to Microsoft Word and put them in your thesis. This table now, you can easily copy this table. Click on it, then right click, then you see copy. By the time you copy from here, you just take it to your Microsoft Word and then you have it in your thesis. Okay, the same thing with this one, the figure, you can copy. Just click on it and right click, then you copy. You can edit, you can do some things as you like. So these things are open. So this is the first thing we'll talk about. All right, the next thing we do, still on the analysis, still again, we use the frequency. Now I don't want to use gender, because gender is just categorical. I want to use something more. Like for instance, the first item that has 7 levels. Again, this one too is what? Is categorical. All right? But it has more levels than that of gender. But again, the difference between this one and gender is the fact that this one is what? Is ordinal. Remember these variables, we talk about them. This one is ordinal, while gender is simply nominal. Rank is not involved in gender, but in this item, rank is involved. Strongly disagree is far different from strongly agree. It's strongly agree has a higher rank than strongly disagree. So this one is the rank. Rank is involved. So that's why it is what? Ordinal. All right. So some statistics can make sense here, so to say. All right. So maybe you can even include quartiles and see the number of quartiles is going to give to us since we just treated the topic quartiles. I want to make mean. By the way, you must note something, and that is in research, there are some literature that you will get that says that if the level in the ordinal variable is 5 and above, 5 and above, you can actually treat ordinal variables as a what? As a interval variable. If the levels are more than 5 and above. You can treat ordinal as what? As an interval. So in this case, mean will make sense, median will make sense, mode will make sense. All right. So let us treat it this way. We're going to talk about the mean, we can talk about the median, we can talk about the mode. These are things I want to involve. Then again, I can pick standard deviation. This under looks at something here. Under here, you have central tendency. And remember the topic, measures of central tendency. And the first column here, you have percentile values. This is where I talk about partitions, the quartiles, the percentile. Okay, and you know percentile, it can range from 1 to 100 percentile. Quartile can only range from 1 to 4, quartile 1/4. And decile, we have decile. Decile can range from 1 to 10. So when you say first quartile, that is the 1/4, the first quarter. Like we used to say, the first quarter of the year. Okay, now we are at the end of the second quartile, at the beginning of the third quartile of the year now. Okay, because we are in July. Okay, so we are at the beginning of the third quartile. Okay, or at the end of the second quartile. Sorry. So because one quartile is over 4, so we have 12 months in a year. If you divide by 4, you will get 3 months. So the first 3 months of the year is first quartile. The second 3 months of the year is second quartile. So we are at the beginning of the third quartile. Okay? So then I talk about decile, which is 1/10. When you partition your data into 10 equal places, the 1/10 is decile. We have first decile, second decile, fifth decile, then 10th decile. Okay? And then we have the percentile, that is over 100. So you have 25 percentile, 50 percentile, 75 percentile, and the whole of the thing. There are relationships between these things, which I'm sure doctor will bring out when he's teaching you. You should know what intersects. Like for instance, the second quartile is the same as the fifth decile, which is the same as the 50 percentile. And it's the same as the median. This is a good question in your exam. Take notes. I won't repeat that. Okay. So the first one is about percentiles, while the second one is about central tendency. The third one is about dispersion, and the fourth one is about distribution. Okay, for under dispersion, we can talk about variance, we can talk about range, minimum, maximum. Then under distribution, we talk about skewness. I think in our last class, this issue came up. The issue of distribution, you cannot run from it. In fact, the whole of statistics is based on distribution. Okay, the whole of statistics is based on distribution. What we analyze is distribution and nothing more. So we can talk about skewness, whether it is skewed to one side or skewed to the other side. Okay, and then we can talk about kurtosis, which is what they call pointiness, whether it is high, pointing high, okay, or it is flat, the height is very low. This is about kurtosis. So these things are something interesting that you can look into. I can pick the two of them. Okay, then we click on continue. And then we click on OK. We expect to get more tables and more results this time around. Okay, now in fact, nice one for SPSS. It has compressed the whole table into one. Let's see how this one will go. Let's see the very first table we see. The question is, in most ways, my life is close to my ideal. Number of valid cases, we have 131. Okay, 132. That means everybody completes this question. There is no missing value. You can see missing is what? 0. Look at median, mean. The mean is 5.32. Just imagine you want to calculate this mean by hand. You know what it means? Let me just take you back to the data set. This data set we are analyzing. If you want to calculate the mean of this, that means we add all these numbers together. You see, you add all of them together up to the last one. and then you divide by 132. You sum everything, and then you divide by 132. Your answer is going to be this, our mean, which we just got now. The answer is going to be this 5.32. This one, just one click like this, the answer is out. And then the median. Remember I taught you the median. You will arrange the data sets from the smallest to the highest, and then you start to count. Cancel one beginning, cancel one the end, beginning, end, beginning, end, beginning, end, begin, until you get to the last number or the last man standing. If the number of observation is odd, you are going to get one last man standing. But if the number of observation is even, you will get two last man standing. So those two, you add them together and divide by 2. That will give you the median. In this case now, if you go back to your data set, these are our data sets. Okay? These are our data sets. We have 132 cases. Median is at the middle. Okay? But that middle must be when you order it. This particular data set now, we cannot easily do that because it is not ordered. This is not ordered. Okay? But we can order it from here. You can see sort ascending or sort descending. Let me do this, sort ascending. Can you now see? From the smallest, it has arranged this place from the smallest to the what? To the highest, which is what? 7. Do you see this now? Okay, so the median, after you've arranged, the first step is to arrange. After you finish the arrangement, the second step, you have to locate the middle. So we have 132 cases here. So the middle will be around what? Tell me, 132 divided by 2. That's going to be 70 or 60. Tell me to know that you are following. What is 132 divided by 2? I'm waiting for your response. So, what is 132 divided by 2? Huh?
Doctor, 66, sir.
66. Good. So that means that the median will be the 66 and the 67. For 2 numbers will appear as the median because this is even. So our 66th cases, look at it here, is 6. Our 67th case, look at it here, is also 6. So the median will be 6 plus 6 divided by 2. And that will give us what? Tell me. 6 plus 6 divided by 2.
6.
That means by this calculation, the median is what? 6. Let's see what SPSS did. Good, thank you. So SPSS did what? What is the answer from SPSS? The median is also what? 6. Then the mode. What is the mode? Tell me, what is the mode? Tell me, what is the mode?
It's 6.
What is mode? What is mode? What is definition of mode? The mode of a distribution is what?
It's the most appearing number.
The value of the highest frequency, doctor.
The value with the highest frequency. The one that appears most times in your observation. Thank you.
The value with the highest.
Excellent. So the one with the what that appear most in your observation. This one we can easily see it from here. Okay. Strongly disagree. Okay, I think it is not even captured here. The number of times it appears. Okay, yeah, that is the agree, right? That is agree. You know, we rank this. Strongly disagree is 1, disagree is 2, slightly is 3, neither is 4, slightly agree is 5, and agree is 6. And then strongly agree is 7. So agree is 6. That is agree. Look at how many times it appears. 65 times. And that is why the mode here is what? Is 6. Do you see it now? Okay, standard deviation. There is one wicked formula like that for calculating standard deviation, right? For group data, the square root of x minus x summation x minus x bar all squared all over n minus 1, whatever. So that is for the standard deviation. The calculation is done here without going through the wicked formula. The software has done that for us. What about the variance? Remember, standard deviation, it has to do with how the scores spread, the spread of the scores in your data set. That is the standard, is a measure. What measure that is standard deviation? The same thing with variance. Both of them, they are the same. Okay? They are the same in terms of what they measure. Okay? And one is related to the other. In fact, standard deviation is what? Is the square is the square root of the variance. So the square of variance is standard deviation. All right. Then we move on to skewness. Remember skewness? Whether it is shifted to one side or shifted to the other side, that's what it calls skewness. And in this case, there are tolerance in research. If you're analyzing your data, there are some literature where it was pointed out that this maximum value of skewness should not be, huh? That's a disturbance, right? Okay. The maximum value of skewness, all right, should be with absolute value of 2. Some research will tell you that, while some will say the maximum should be absolute value of 1. If the skewness, here it is minus 1.5. If the skewness is more than 1, that means your data set contains excess skewness. That is, it is not normally distributed. Okay? And the same thing with kurtosis about pointiness. If it is up to 1, it contains excess kurtosis. While some researchers will say if it is up to 2 and above, if it is up to 2, like in this minus 1.5 is still okay because it's not up to 2 absolute value. And this one 1.5 is some researchers say it is still okay because it is not up to what 1. It's not up to 2. So these are the 2 measures of distribution which we have got. All right. So the next thing here, apart from the skewness and the kurtosis, is the range. The range means the highest value in your distribution minus the smallest. Our highest is 7 and our smallest is 1. So the range will be 7 minus 1, which is 6. You see it? So the minimum is 1, the maximum is 7. So the range is 7 minus 1. I want to test something. Look at percentiles. Remember, we click on quartiles, right? But I clicked on quartiles. However, this particular table is giving me percentile. What does this tell you? What does this tell you? Tell me, what do you make sense out of this? Remember, I chose quartiles. And I told you, quartile will divide your distribution into 4. We have the first quartile, second quartile, and third quartile. But percentiles will divide your distribution into 100. Okay? But here I asked for quartiles and it gave me percentiles. See, this relationship is very important. 25 percentile. This is how you call this one. 25 percentile is equal to 5. What that means, 25 percentile is the same as the first quartile. I repeat, 25 percentile is the same as the first quartile. And it makes sense. How does it make sense? 25 percentile, that is 25 over 100. And when you divide 25 by 100, tell me, what are you going to get? What is 25 divided by 100? 1 over
1 over 20.
1 over 4.
1 over 4.
1 over 4.
1 over 4. 1
Yes,
over
sir.
4. That is the first quartile. 1 over 4 is the what? The first quartile. I hope this is clear. One over 4 is the first quartile. 2 over 4 is the second quartile. 3 over 4 is the third quartile. So 25 over 100, which is 25 percentile, is equal to the first quartile. Write it here for you. 25 percentile. Okay, 25 percentile equals what? First quartile. All right. Let's put it in the chat. 25 percentile equals to the first quartile. So the first quartile equals to 5. The second quartile is the same as the 50th percentile. 50 percentile is the same as the second quartile. How is that? 50 divided by 100. What do you get? What is 50 over 100?
2.
1 over?
1 over 2.
1 over 2. Half.
Yes,
That half I just mentioned should tell you something. Let's hold on with that. 50 over 100 is what? Is half. Second quartile, thank you, in the chat. Second, 0.5 is half. Second quartile, that is 2 over 4. What is 2 over 4 if you reduce to the lowest term? 2 over 4.
1 over.
That is
1 over 2.
sir.
Same half. That means 50 percentile is the same as the second quartile, which is the same as half of the distribution. Half of the distribution is what? Tell me. Half of the distribution is what? Hey, jam question. Half of the distribution, half. I want you to say it from what you have here. Is it the mean? Is it the mode? Is it the median? Half of the distribution is the middle of the distribution.
Yes.
Is it not?
Yes.
Half of the distribution is the middle of the distribution. That means half of the distribution is the median.
Yes.
Is the what? Median. That means 50 percentile equals to the second quartile, which is equal to the
third quartile.
Median.
Median.
Yes, median. So 50 percentile equals to the second quartile, which is equal to the median. Let's see whether SPSS knows what it's doing. 50 percentile is 6. What is our median you see here?
6. Yes.
6.
They must be the same.
Yes.
Our median is 6.
Yes. So our median is the same as the second quartile, which is the same as what? As the 50th percentile. Okay, thank you. What about the 75 percentile? Remember, I click on quartiles. Okay. Now, and then this SPSS gave me 75 percentile. So that means 75 percentile must be my third quartile. But how?
Third quartile.
How? Just do the small calculation. 75 divided by 100. 25 in numerator, 3. 25 in denominator, 4. The answer is 3 over 4.
3 over 4.
And 3 over 4 is what? Third quartile.
Quartile.
Is this okay?
Yes.
If this is the only thing we achieve today, I'm fine. So 75 percentile is the same as the third quartile. 25 percentile, 25, is the same as the first quartile. 50 percentile is the same as the second quartile, which is the same as the median.
Median. Okay.
75 percentile is the same as the third quartile. Amazing. So we've got what? That is the end of the distribution of this table, or interpretation of it. Let's now go to the second table, which is again about the frequency count. So the question, in most ways, my life is close to my ideal. We can see a lot of people disagreeing with it. Wow. So that means people are satisfied with the current situation, with this Tinubu economy. Eh? Because remember, this questionnaire, you feel this questionnaire, you people in this class, the questionnaire, that's what you feel. And the answer now is a replicate of what you are telling us or what you want us to know about your current situation. So if I was the one that feel this, perhaps I wouldn't have chosen strongly agree. Maybe I will say strongly disagree. It's not close to my idea. I still want more than what I have now. So in most ways, you say my life is close to my ideal. We have quite a lot of people agreeing to this statement. You can see slightly agree 24, agree 65, strongly agree 20. Wow. So some people think Tinubu economy don't affect them. They are just faking it, yes? So this is what we have. So this is about this is just about frequency count. Now let's now go to the bar charts. You can see how the distribution goes. You have strongly disagree, and the topmost one. And you can see that's why it is called the mode. The one with the most frequency is always the tallest in the class. Can you see it now? Interesting. And again, something I must mention before we leave this analysis is the fact that for a normal distribution, remember, normal distribution, the mean, the median, and the mode must be equal or approximately the same. The mean, the median, and the mode, they must be approximately the same. Are we okay? Okay, yeah. So as I'm saying, the mean, the median, and the mode, they must be the same for a normal distribution. In our case here, we can see the median and the mode, they are the same, but the mean is different. Can you see that? The median and the mode are the same, but the mean is what is different. So because of the difference in mean, this particular data set will be slightly not normal, slightly. And that's why you can see the keto, the skewness and the ketosis. they are not that much. At least if you choose 2 as a yardstick. So this is there. Okay, let's now go to a situation whereby we want to differentiate between males and females. Okay, if you want to do that, we are through with this side. If you want to do that, you can come to these descriptives instead of the frequencies, right? Maybe not. Maybe we use explore cross tab. But again, there is something more I want to do, which is about the shape. Let's bring in the shape. For our frequency count, which you have the same data set we've analyzed, when you come to this chart, we can ask for the histogram and then show normal curve on histogram. Instead of taking pie chart, let us give us the histogram so that we see that bell shape, whether it comes out or not. This is important to do. And then we click on OK. All right, the same table as before, but different chart this time. And can you now see different chart? You can see that the distribution. Remember something. The mean is what? 5.3. Look at it. The mean. Look at the top of this bell shape. You can see the mean will be somewhere around here where I put my cursor before 6. So the distribution is somehow close to normal, but it is not. However, it's not that deviated from normal distribution. And if you are analyzing the data, there are some statistics that we can take care of this small deviation in normality. T-test will not do it, but ANOVA can do it. When we get to 802, you will learn more about these terms. So this is a little bit deviated from the normal. ANOVA can take care of this one, no problem, without necessarily using non-parametric test. So this one is fine. All right, we've got this. You can do more. Still again on the description, since I picked the first item, let me pick the second item this time around. Okay, then options, what are options available to me? I can also select the way I did before, the range, the distribution. This is almost the same as the previous tab, which we have used. Okay, and the variance. Then you click on OK. Let's see something else. Perhaps we're going to get more. Then we click on OK. All right. So you can see instead of presenting the table in a vertical form, we now have the table being presented in what? In horizontal form. Again, you have your number, your range, minimum, maximum, mean, standard deviation, skewness, and so on. And the values remain the same or a little bit different as the case may be. So this is what we have. We can still do more on this cross tab. Let us see where we can combine two variables together. Let's come to X. This is where you can combine two variables. Like now, you want to know male and female differences in the first item. Male and female differences in the first item. So you are going to pick that particular variable, which is this one. I push it to dependent variable. I want to use gender to slice the variable. So that gender will now be your factor. Okay? The variable of interest is the dependent variable. You put it in there. And then your slicing independent variable will be the what? The factor. Then you talk about the statistics that you want. I want descriptive statistics. This is important, outliers. And one of the essence of doing exploratory study, exploring your data, is to look for these outliers. Perhaps when you're entering the code manually, you made a mistake. Instead of 18, you write 81. You will not know. But by the time you run this by the time you explore the data, the outlier will come out separate. And then you can remove it from the data set and go on with your study. I can also put percentile if I want. It's good. Then I click on OK. Then what about the plot? Which type of plot I want? I have stem and leaf. I have histogram. I also want normality plot with test. I want plot and test to come out together here. Then we are not transforming the data. We leave it as it is. Anything in the option, nothing more, only this one. The none here is very important. Do you want only statistics? Or you want only plots? Or you want both statistics and plot? I want both statistics and plot. Then I click on OK. All right. By the time you do that, just leave SPSS to do its own. In microseconds, your answer is out. Now you can see something that is important. We have the item written here, being sliced by gender, male and female. So male students who fill this questionnaire and fill this item, there are 75, and female, there were 56 percentages in there. That is good. Now look at something here. Instead of we having mean, standard deviation, and all these descriptive statistics for all of them, we now have it for male alone and for female alone. So for male, the mean is 5.24. But for female, they have a slightly higher mean, 5.41. Aha. The median for male is 6. The median for female too is 6. Okay? The range for male is 6. The range for female is 6. Ah, look at this one. Interquartile range. Maybe you have not been taught, so I should just be quiet about it. But you'll be taught very soon. Interquartile range. So we also have interquartile range to be the same. But what about standard deviation? Are they the same? Standard deviation for female is 1.487. While for male, the standard deviation is 1.6. That means there are more spread in the male data set than that of the female data set. That's what it means. And the higher the standard deviation, the higher the variance. Look at variance for male, 2.8. And the variance for female is 2.2. So there are more variability in the male data set than that of the female. That is the essence of this one. Okay, the next thing we go into is the percentile. Look at this, is very nice. Since I didn't take quartile, it gave me 5 percentile, 10 percentile, 25 percentile, 50 percentile, 75 percentile, 90 percentile, 95. Remember, 25 percentile is the first quartile. 50 percentile is the second quartile. 75 percentile is the third quartile. I repeat, remember, 25 percentile is the first quartile. 50 percentile is the second quartile. And 75 percentile is the third quartile. Good. We got that. What about extreme values? Okay. Highest, lowest, so on. In this case, there is no problem because we did it using computer-based form to generate the data. If you have used manual, paper and pencil, people will make mistake. And even you, when you are typing, you make mistake. But with online, no mistake. Everything is in there. Yes. We now come to test of normality, whether the data set is normally distributed or not. There are 2 tests here. We have the Kolmogorov-Smirnov, then we have the Shapiro-Wilk. Ah, interesting names. Kolmogorov-Smirnov, then we have Shapiro-Wilk. The null hypothesis here is that the data set is the same as a normal distribution. The distribution of the data set is what? Is normal. That's the null hypothesis. So a significant test here means that it is not normal. Now the distribution for male is not normal. The distribution for female is not normal. For both tests, they confirm this. You can see the p-value, that is SIG, significant value. The p-value is 0.000. That means the data set is not normally distributed. Maybe you want to see more about the stem leaf. This is what they call the stem leaf plot. It's also interesting. Okay. And then for male and female, then we have the QQ plots for the normal distribution. You can see deviations for male and female. And then the QQ plots also. You can see our QQ plots now. If you just join these dots together, you will find that there is a little skewness, and it's very close to that one we got before. When you join these dots together, that's what QQ plot will do for you. But this one is for male, and then for female, QQ plots. Look at this one, is even far deviated from that. Look at it. It's far deviated from that of the male. So I think we also have the box plot. Yeah, interesting one. Look at the box plots. The box plots has covered only this top, and this bottom, they are more or less like outlier. In fact, there is a recommendation for you. This one will start. It is recommended that you should remove them from your data set because they are far away from others. These stars, they are telling you that you should remove them from your data set because they are far away from the what? From others. So this is what we have. I think this is the convenient place for us to stop today. The video will be available for you to watch as time goes on. Maybe by Sunday maximum, you should find it in the YouTube. So any comments before we round it up in 30 seconds? Any comments, questions, recommendations? I think I can stop recording now.